Welcome, everyone. Thanks for attending today's session. We are presenting on effective search deployment and operations in SP 2013. My name is Christopher Loranger, and this is Brian Pendergrass. And he and I are both on the Premier Field Engineers, or PFE, that you see there. And we're on a team that we focus on all things search.
So I've been working with SharePoint for about 8 years, and now focused primarily on search architecture, troubleshooting, and performance. I co-led the development of our internal search training for our search engineers, and presented at SharePoint Conference last year on how to manage and troubleshoot search.
I've been with Microsoft for 7 years. I came with a fast acquisition, and I've been working with Microsoft Search Technologies ever since. I was at SBC 14 presenting on a similar topic to today. However, this is an evolved version built around best practices and from what we've learned in the field with our customers. A lot of this content was built off of who we talked to in the support organization with support leaders and our team.
I can get that down. So our role as Premier Field Engineers, we're also known as dedicated support engineers, and we're tasked to help our customers get the most out of their implementations through proactive and a lot of times reactive engagements. Simplistically speaking, we kind of fit the space between MCS and support. And our team's a little unique in that we focus entirely on search. We primarily in SharePoint, both SPO and on-prem, but we also have a lot of depth in fast search and Azure Search too. And the types of clients we work with, they span anywhere from the boutique shops with deep specialization to huge hardware vendors, large pharma, telecom, oil and gas, and public sector. So I mean, we kind of span the gambit when it comes to the types of customers we work with. And the types of engagements we have too, I mean, they go anywhere from the short-term projects to long-term dedicated engagements too. So I mean, we've seen lots of scenarios in lots of different contexts throughout the process and the product lifecycle. And pretty much the goal of today that we're trying to do is bring all of that we've kind of that we've learned through these experiences, compress it all the way down into an hour, and try to deliver it here today. So seems easy enough. I mean, because search is basically just one of those things you turn on and let it go, right? So yeah,
yeah, right.
So being said, boop. Next slide.
Next slide. All right, you can use the mouse.
Oh yeah,
too.
there we go. So is this normal? I mean, this is the most common question we get, and admittedly, our most common response and favorite answer is, yeah, it depends. So, but I mean, whether we're talking performance or troubleshooting or even how some functionality works, I mean, the real answer boils down to your baseline. I mean, for example, I jokingly call the crawl component a denial of service in a box because it just hammers web front ends with web connections. And so, I mean, it's answering things like, can your web front end handle that traffic? You do all the search architecture and everything, but then you point it at a web front end and it just falls over. And things like, looking at a normal crawl rate for your environment, but is it the same whenever you stand it up and you set your specs for one crawl? What happens when you get multiple going on at the same time? And we see that a lot. I can crawl one content source great, it works fine. I go into production, I have 60 content sources, and things fall over. So it just doesn't handle that scale. So just understanding that baseline and being real, using real world scenarios in your test. And similar to with queries, I mean, just how many queries per minute can you sustain? I mean, testing that too. And make sure you test when there's crawls running because that's going to have an impact on the back end index too as you're crawling. So this baseline is going to become your foundation for the rest of your task. I mean, anywhere from monitoring for problems, measuring performance, spotting trends, or even planning your architectural changes. I mean, they're all going to be relative to this baseline, and that's what we're going to try to illustrate in this session today.
Yeah.
Oh.
You want to try doing that? We just lost network connectivity.
Oh yeah, so that's going to hurt demos here in a second.
Yeah, but
good old network, but we're fine right now.
Sure.
So anyway, so these are just kind of the summary. I mean, just to kind of look at as we're going through this. I mean, just doing things like automating tasks so you don't have to do them by hand, and again using that baseline. It's a continual cycle of improvement. So just going through, and we're going to talk about all of these things. The same thing with security update and sizing, migration, and whatnot. So again, all of this is going to tie back to the baseline here.
take that. So just a little refresher for a high-level overview search architecture. There's 6 main components to search. So your content's crawled or gathered from your sources. Those sources can be SharePoint content, BCS, file shares, that kind of thing. It's then processed by your content processing components. There can be calls out to web services to enrich your data. And fed to the index where parts of your content is kept on disk. Can you get this online? It's online. There you go. So the query bits, this works magic with your user's queries, sends it back to the index and other federated sources. There's an analytics piece that builds usage reports and helps with relevance by taking events, click-throughs, and getting content for, thank you, for just creating a better search experience. We'll use this slide in reference and laying down a color scheme throughout this presentation. There's some names here you will see in ULS and documentation I want you to be aware of. The query and index parts, we'll do a much deeper dive. So if you're just planning your architecture or you're about to order hardware, this slide is going to be your #1 takeaway for gotchas. Or if you're already set up and you're seeing maybe some performance issues or there's explosion in growth, this is going to be a great reason why. So again, this information is from our support leaders in collaboration with our team, finding the most issues and with experience. And the 4 that are really worth a call out here is antivirus. Your index, antivirus, antivirus, antivirus. Can't say that enough. Your crawler and your index write a lot of little files really, really, really quick. So we need to make sure that there's exemptions put in place there. We have some blogs that we're going to show. We're going to show you at the end of this. So if you don't get this slide, not really a big deal. We have this as a #1 blog post later on. Your data directory. Consider your OS, your app install, your ULS logging, and search data paths before you even start. This is none of these things can be set after you install SharePoint on these systems, excluding the index directory. IOPS requirements. You want to test your connectivity. We've had a couple customers that do the very minimum here, and they pay for it later with query timeouts or during high peak usage of crawling and for queries. There is great guidance on TechNet around this, and we've also built a SQL search wrapper, and that's in our blog as well. Again, we'll show that at the end.
And so part of the blog that he's mentioning too, at the end of this, we're going to link out to our team blog, and it's got all the references that we've got that we're making. So if we're saying look in the blog later, when at the end we'll show the link to it so that you'll have all those for future use too.
Okay. SQ and SS, the spelling is out there, should be running on servers that have a QPC or query processing component only. The SQ and SS is started automatically when a QPC is provisioned. A lot of customers, they'll make a lot of topology changes. SharePoint loves to start a process and not turn it down. Just remember that. If you made a few topology changes and you're receiving the old something went wrong, this is one of the primary reasons why.
Yeah, we see this commonly, and a lot of this spawns from the behavior in SharePoint 2010. I mean, the search query insight settings, for all intents and purposes, was the query processing component for 2010. It's what, and this piece is still here, but it's largely there for almost like, I don't say legacy, but it's still for backwards compatibility because the web application is talking to the search query insight settings. And so, I mean, what we saw in, say, 2010 is you would just start this all over the place. I mean, start it on your web front ends, and it can be separate from your query process or your query components in 2010. But in 2013, I mean, it's really more or less a wrapper around the query processing component and does just a little bit of routing that we'll show here in coming up slides. But you don't have to worry about starting it. Search will start it for you where it needs to be going. But like Chris said, I mean, we have seen some weird cases where you started on too many servers and you start getting a higher rate of occurrence of, hey, sorry, something went wrong. And it's just those endpoints timing out.
Just a quick note to the team. Can we get someone up here to help out with the internet access? It's non-existent or
So
having
our
issues.
demos are going to be deferred to the end.
That's fine. We have plenty of slides to talk about before we can do that. That's not a problem. So to show some flexibility of the architecture, we can first think of the classic on-prem SharePoint environment crawling content farms and other content. And then we add a next stage, common scenarios with a lot of businesses these days that they're slowly moving into the cloud, like my site's OneDrive for Business. We see that so many times, right? And that's probably happening. But users want to start finding that content in search, but they're having some limitations if you set up a hybrid environment, mostly relevancy or usability, putting separate indexes and verticals, that kind of thing like that. So coming end of 2015, the Cloud SSA, which is a new type of search service application, will be a smaller footprint farm with just a crawler search admin, the crawler and the search admin that can live in multiple locations. Think scale up and scale out with multiple content SSAs, putting this in many data centers. And the search index will live in one place, like in the cloud. So users can search from O365 or on-prem sites where relevancy is computed across the entire data set. And they'll find the content they're looking for in a single unified search experience, including Delve.
And so last night in Ask the Experts, we had several questions come by asking about Delve and on-prem. And I think partly that was just the message came out wrong yesterday, but essentially Delve is still cloud only. It's your content is being crawled from. Your content is being crawled from on-prem and pushed into the cloud, and then it's the on-prem content in the cloud that's getting the Delve signals added to it. So Delve is still cloud only. So
I know there's going to be a lot of questions on this, and there was at last night at Ask the Experts. I really, really ask you to go see this presentation tomorrow at 5 o'clock.
That's where they're going to be deep diving into this, and that's so really kind of the point for us to even bring this up is to show that it's an architectural option, but really the deep dive. We don't want to ruin their thunder and step on their presentation early.
Yeah, exactly. Definitely something to look for, though. It's coming up soon. And here we go. So where else can the cloud help out with your organization? Microsoft Azure IaaS. In this slide, we talk about some steps to create a DR environment for your on-prem search investment in Azure. Yeah, it's not even connected to VPN. So first steps you want to do is create a virtual network in Microsoft Azure. And again, these are all built off of the SharePoint DR strategy, but if you have a search farm, you can use this as well. Connect the on-prem network with virtual network in Microsoft Azure with a site-to-site VPN connection, or even ExpressRoute, which is excellent product for Azure now. Deploy one or more domain controllers to your your Azure environment. These can be configured as like DC catalog servers. And then you can adapt your SharePoint search farm for cloud services and availability sets. This can be scaled down version with less replicas and no high availability. And you can back up your SSA. And then you can restore your SSA between the on-prem environment and the Microsoft Azure base recovery environments. So depending on your SLA, there are some flexible options here. Warm standby mode, running, taking resources, crawling as your production environment's running. Or you can have a cold standby mode where you only fire up the VMs when needed. This saves you so much money. And just a little FYI there, you can. This needs to be in the July. Your CU patch set needs to be July 14 CU to do that. Restore the index part in different locations.
Right.
Okay, so you have your environment set up, and now you want to be proactive, right? I'll touch briefly on each component to keep your search environment up and returning fresh results. The main takeaway here is that you need to find a baseline. You set alerts on those thresholds. Everyone's environment's different, but this should give you a great start to monitoring. So your crawler components. Again, your crawler takes the content in, creates a lot of little small temp files really, really quick. You want to send an alert to yourself or to your support organization before that fills up. It's built into the SharePoint 2013 management pack for SCOM. It's there, you can see it, and all of these thresholds will be there too if you run procmon and just reconnect. Let's see. Yeah, just check the internet real quick. So the threshold value here is a very important feeding data point when troubleshooting for your content or doing some content tuning. The data point shown in graph form in the crawl load report under your SSA. It just wasn't plugged in. Is it plugged in? No. Have you tried unplugging and plugging it back in again? Excellent. So you
I can't see. The lights are out.
So what you need to know there, though, is that a high level is okay, as long as it's steady and plateaus. We wrote a great blog report about it, and we have some great analogies we talk about a little bit later on. That's why you see N here, because everyone's environment's different. Again, the takeaway is baseline. All right, so a little simpler, the content processing, it's up or down the connection, alert if it's not working. Your input queue full time doesn't change, or it never goes down, or there's spikes. You can set a threshold on that. For your index, you want to alert if there's a cell that's degraded or down. Okay, great. And then there is a software boundary for each partition for 10 million documents. This is very well documented in TechNet. If you have 2 partitions, you can have 20 million documents. After that, you start seeing some performance issues. So alert on 9 million, 9.5 million. Then you can alert before it's a problem, add another partition, scale up and scale out. Hey, it's connecting, yay. Query processing, there's an alert that search is down. Search is down, that's bad, right? So check this QPC, make sure it's up and running. Hopefully you have more than one QPC. That's best practice to have that HA set up. There's a great threshold for QPS to do 3 queries per second. That's a great start, but you can tune that to your environment. Again, this is a QPC for this alert on 1 QPC. So if you have, again, it's about baselining for that. So one final one out of the 6 or 5 for search. So the analytics part. You're going to get some failed warnings. You need to just kind of set a threshold here. You don't want to see more than 1 failed per 24 hours. And the threshold for analytics, every task, or the whole job is broken down into tasks. You don't want to see a task that's longer than about 6 hours. You definitely don't want to see all those tasks longer than 24 hours. So let's fix that before it becomes a problem. Takeaway for these slides on monitoring, again, baseline, be proactive as search grows, and it will. You'll see 20 million documents, then the next day you'll see 35 million documents. It happens. So that's the architecture overview and some monitoring about being proactive and some baselining. Brian, let's hear about search topology.
Okay, so simplistically speaking, the search topology really just an object that defines the mapping of logical components to where they're physically deployed. And we kind of see this illustrated here in the search topology script or UI from Central Admin. In SharePoint 2013, you can only modify the topology using PowerShell. And as Chris demonstrated at SharePoint conference last year, we have scripts that really simplify this process, and we'll have those linked in the final blog post that we've been referencing. But today we're going to spend more time focusing on the operations aspect and how to monitor the system once it's up, once it's in place. So again, screenshot from Central Admin, just looking at the components. And it shows us all the components and things that are seemingly healthy, and kind of it gives a quick indication of what's going on, and that hey, everything's going good. But there's a lot of key information here that's missing, and you're really limiting yourself if you're only using this as a way to monitor search, especially when anything heads south too, because it's impossible to figure out what's going on from this screenshot alone. So. And the first one I want to talk about is an unseen admin component that it's not technically an admin component, but it's really more of a timer job. And it's the Application Server Administration Services timer job.
Remember that name. This is something you will run into.
And it's an extremely important timer job that runs once a minute, or at least should run once a minute. I've seen several cases where it's disabled for weeks, and it causes problems. But it should run on all the servers once a minute, and it performs a ton of administrative tasks. And we see nothing about that in the topology view whatsoever. So it's almost like a missing admin component not showing up in that topology. And the name of this drives me nuts because the name of that timer job says nothing about search. And I remember the first time I found it, it was like, what timer? Oh, that one? Yeah, and it will kick you at least once. And so here's kind of a taste of why it's so important. And when the timer job runs, I mean, what you're going to see is a message like this in ULS. And notice this is from OWS timer process 2. We kind of blocked off each of these messages, so kind of you'll see them together. But when this runs, it basically synchronizes the configuration from the search admin database with all the search service instances on the server. So basically getting all the processes in kind of the expected state, just before they even do what they're supposed to be doing as an application, from the application perspective, just standing up the processes. It's going to persist all the objects to the SharePoint configuration cache. So if you've had any of those issues where update conflicts and you had to clear the configuration cache, I mean, this is one of those that hits that. And it propagates the search schema throughout the entire search system. So basically that's important because as, say, your content processing component are discovering new crawled properties or anything like that, which then get mapped to query properties, and then later downstream, you go to actually, so those get pushed into the admin database and then propagated back to the query components too. So when you go to issue a query and you're using a managed property to do a query and it doesn't show up, this is probably why, because it's not being propagated into the database. So if I try to use managed property filter, basically the query processing will look at it and say, I don't know what that managed property is, so I'm going to treat it as a text. You're looking for that as a string rather than treating that as a managed property. So this the schema propagation is incredibly important for a healthy system. And if there's a crawl component on the server, it does even more. Basically, when the job fires, this timer job is responsible for the initialization of the gatherer application or crawl component, if you will. I mean, this is where the crawl component is going to be, creating all the applicable registry keys, temp path locations, and the file share that it uses for feeding the content processing component. If you've ever had one of those scenarios where a crawl component's in just weird, unexplainable state and can't figure out what's going on, or crawl's hung waiting on crawl component, I mean, more than likely you're going to find your answer here in this particular timer job running once a minute. There'll be an exception here on the synchronization. But anyway, so, and if it's the primary admin component where this is running, it's also going to do things like synchronize the legacy admin. And really all that is, there's a searchadmin.svc web service that's running in the system. And that basically is when you go to central admin and you see all the, apologies for that. And you go to central admin and you go to the search admin webpage and you see all those web parts that are running. Most of those web parts are populated by this search admin web service. So this is the synchronization of it, getting it going. Again, tied to this timer job. But it's also triggering master merge. Every 15 minutes, it's going to go and talk to every one of the index replicas and say, hey, have you met your thresholds? Do we need to kick off a master merge for that component? And the same thing with the synchronizing the constellation. So in one of the earlier slides where we had kind of here's the topology of everything, and here are all the different labels. If some of those had node runner processes that the components were running as. Basically, all the components other than the crawl component are running as node runner processes. I mean, and in those, they're part of the, I guess when we combine SharePoint and Fast into one product in 2013, we still more or less have a Fast system, if you will, under the covers that's going on. And the collection of all those node runner components is essentially known as a constellation. It's a topology-like concept. But basically, this timer job is also synchronizing the constellation information with the search admin database as well. So if you notice in the last ULS message there's no crawl component actually listed there. It's all the components but the crawl component. So it's basically synchronizing that information back into the search admin database. And so the key takeaway should be, I mean, don't worry explicitly learning about each one of these things. The key takeaway should just be, know this job exists, know it touches a lot, and the weirder the issue, the more likely this thing is involved. So again, kind of looking back to the slide, the topology report, it's pretty limited when we're trying to figure out what's going on. I mean, hey, Chris, want to blindly guess what I did to cause this?
Reboot it.
Yeah. So, I mean, and that's kind of the point. I mean, we see there's some problems going on, but we have no idea what's going on here. So I mean, really to get this any sort of additional information, I mean, PowerShell is the way to go. And one of our product group members wrote this script. It's public. The how to view the status of the SharePoint 2013 search service. And basically what this is going to do is it's going to show some key information. I mean, things like overall indication of system health, topology status, information about the primary role for both the index and admin components. It'll tell you which one those are. We'll see job statuses for the analytics components and some crawl statuses too. So what we did is we actually took the script and extended it out so that it actually goes out and looks at the looks for the running of the application server administration services timer job, which y'all should know what that is now. So basically goes out on all the servers, and that's basically going to be our first demo here.
8.
Yes. So as you can see, and just so we, boop, not used to this mouse. There we go. So as you can see, so I refreshed it. Topology looks healthy. It's all fine. No big deal there. But as we run this script, your mouse is dead, man.
Or is it just slow? Is the connection slow to the...
I don't know. Can you break?
It working a second ago.
We thought we were going to do a demo.
Oh, you're kidding me, right? All right, well, hey, let's move on and I'll fix
Worst
this.
case, yeah, we'll hit demos at the end. I mean, they'll still be in context. But,
Okay.
but again, what I was going to show was the application services timer job
5.
not running on a server. It's good times. So let's kind of move on to some availability and performance. So in most of the reference architectures I've seen, including TechNet, you're going to be something like this. And they're going to show these hardware specs and as kind of your minimums of what's going on. But I'm just going to say, be careful here. Because if you notice, all of those index components, they all show 4 CPU core minimum, 16 gig, 500. It's the same across all of them. And it's basically saying the query component's free. It doesn't need any resources. It's just throw it on there, whatever you want. And so basically what we're going to do is the next slide. And basically that assumption is built on you've got a low, not doing a whole lot of queries. Basically a low query per minute threshold. And so just kind of digging into this one. The index component, we have specs out on TechNet that basically say that a query component can handle, that an index component can handle about 5 query lookups per second per CPU core when there's 1 million items in the index. So if we look at that same architecture, say 4 cores on this box, and we have 4 cores times 5 queries per second, we're going to get and see on the bottom right, you'll see about 20 queries per second that this index component can handle, just off basic numbers. Throw a query component on there, and we also have guidance that basically says that the query component can handle about 4 queries per second per CPU core. And most of the tests I've seen, these are pretty accurate, but if you notice, even logically speaking, you can't have an index lookup without a query that happened first. So as you put this under a load, essentially what you're going to have is these are going to have an equilibrium. And so you're going to have about the same number of queries being made as you do lookups actually occurring. That cuts our resources in half already. So, and it's already dropped our queries per second for this box down to 9. We were at 20 a second ago. Just adding the query, now we're at 9. But it changes even more whenever we add more items into the index. So that guidance goes from 5 queries per second to 2 when you have 5 million items in the index. And so, again, just looking at the equilibrium, we're down to 5 queries per second. And you add in 10, take it up to its maximum 10 million items per index component. And that query per second for the index component is going to be down to 1. And so now we're down to 3 queries per second for this box now. And it gets worse. That assumes that, again, you don't have a whole lot of query rules. They're not very complex. If you do, when you start doing really heavy-handed query processing, query rules, things that are using like regular expressions in your query rule, those are CPU intensive and those are going to steal cycles. So if you have a bunch of them going on, that's something to be careful of. That's going to drop the queries per second that the query component can handle. But another one is that if you have a query rule that goes and fires off like 5 more queries to other things, that's not going to actually lower the query per second that the query component can handle, but the perceived queries per second is going to go, it cuts in 5. Because the your user issues one query, but in the back end, it's issuing 5. 1 to Bing, 1 to SPO, 1 to on-prem, 1 to whatever. I mean, so you get 5 queries going on, but the user only said, I just issued 1. So it's going to lower even that too. So point being is the query processing component is not free. I know that a lot of the guidance says, or almost implies that it is. Just kind of be careful for your environment. And again, this goes back to the baseline.
Yeah, and also there's an impact on resources once you hit 10 million.
Right. And so you may have seen this type of slide before. I mean, we try to really minimize the number of slides we reused from other presentations, but this one you've probably seen in another form before. But it probably had diamonds on it, or in TechNet, I think it's teardrops or water drops or something. I'm not sure, some sort of symbol. I don't know what that means.
Minecraft blocks.
Yeah, so we changed it to high, medium, and low. Figured that was a little more easy to understand. But really, kind of the big takeaway from this is, just try to avoid, similar spec'd out, type components. You don't want to put your content processing component on the same one as your index box. So, but if you want to learn more about performance and scaling, recommend checking out Friday, the Properly Scale and Deploy Enterprise Search session going on.
Yeah, Paul Summers and Dan Benson, great guys.
So to kind of wrap this up with some availability, now that we're looking at this architecture, when you go to patch, you don't want to take your system down just so you can upgrade it or update it with other patches. So basically, just a strategy here to kind of help you minimize that. If you have multiple components going on, so that you do have that high availability, this can help you out in terms of just to keep it up while you patch. So basically, what you want to do first is identify all your index components and where each of the primary and secondary replicas are for each of those partitions. And then same thing, you also want to identify your primary admin component. And once you've kind of identified those, basically you want to upgrade everything else. So we've kind of looped off here. The top row, we're not including the primary admin component on the upper left or any of the primary index components either. Once you get into some high density scenarios too, where you have multiple index components per box, this gets a little more tricky, but I mean, the concept is you try to at least leave one replica per partition available that you're not upgrading right now. It doesn't necessarily have to be the primary, but it's just better if it is. So you isolate all those and you upgrade those first. And that also it has an assumption built in there that we got idle crawls, because we're updating the content processing components here too, is what we're saying. So make sure your crawls have come to an idle state. Be careful just stopping them, because if you stop a crawl, then basically that forces a full crawl the next time. But make sure they just come to an idle state and just disable your schedules. And then after that, after you've got all these upgraded, then you can go for the remaining set of your index components once everything's back up. And then finally, your primary admin component. And then while we're talking patching here, we always advocate going to higher levels. But I mean, if there is a minimum that we would recommend,
Yeah, we have customers say, what patch set should we be on? December 2014 CU.
Yeah.
It has so many fixes, a lot of feature sets, and that's what we recommend. What we absolutely recommend.
It's kind of a baseline minimum.
But we release them every month for underneath the SharePoint CUs. And also, this strategy, translates on-prem VMs,
right.
On the cloud VM or Azure IaaS. All right, cool. That's good, by the way. So relevancy, really, we want to talk about that next. Just a brief touch on it. This is something that we could present on all day long, and we can talk about it later if that's something that's important to you. But as a search admin, relevancy is really an opportunity to give a rich search experience to your users. Tuning is an investment you have to make. In any search engine, there's no set it and walk away. No one's data really looks alike, right? So but we do give some great tools and reports that you can use to find trends. So query rules, number 1, use them, learn them. They are something that if you're a search admin or going to be a search admin, this is something you're going to do almost every day, if you're a search admin or even a business user. Let's see. Did I say that they're .NET regexes? So this is going to convert a user's query into something that almost looks like magic, right? Your organization has a specific set of terms. You want to create dictionaries to cover these. or manipulate the data by enriching it before it even gets processed, or even at processing time. The usage reports on the SSA or the O365 Admin Center are an amazing resource for finding trends. This is something that you find with your users, what your users are searching on, like top queries or even queries that are not showing any results. With this intelligence, you can create query rules around those trends to give users a better search experience. And speaking of query rules, how many people see this every once in a while? So if you're a search admin, you get really good at creating query rules. You're not so good at deleting those, right? It's just another admin job that you need to do. So they become really difficult to manage once those start getting into dozens, hundreds, and thousands. I think we have some customers with 5,000, and that's about the limit, right? And even then, that's pushing it. So Eric Dixon on our team wrote an amazing seek and destroy script for you to do this, to find all of those and remove them. It's not such a great name, however. This has saved me so much time working with customers to find these and delete them, and it will for you. Check it out. Again, this is #1 in the blogs that we post later on, where to find that. So last year at SBC 14, we got some great feedback from you guys following the life of a document through a crawl and illustrating the key ULS events. And we heard that request to do the same for queries. So that's what we're going to do today, and it's going to help you visualize the flow of that. So user queries originate at the WFE. So whether you're talking the query web parts in the Search Center, or even queries coming in from the client-side object model, you go through an internal query OM. It then invokes the default SSA proxy, which routes the query flow to a SQNSS and chooses which one in a round-robin order. The important part here is that AAMs, SharePoint site, and security contexts are all looked up and established here in the SSA proxy before it even leaves the WFE.
And we'll see a callback to this context later on in another slide when it goes out to SPO.
Absolutely. So the SQNSS acts as a router to the query processing components, and it does so based on load. So the fewest number of running flows in the QPC, which we can see here from the ULS message. Also from the net.tcp endpoint here, we can see which QPC the query is being sent. So for example, QPC 1 on query server 1. Did you find something wrong? You're something wrong page, you get a correlation. You can look to see what the correlation is, and that query processing component's down or having issues. So this is effectively the first event you'll see by the QPC when it receives a new request for a query. And from this, you can also see the query template being used too, which impacts query rules. So what's happening inside the QPC? Let's expand on that blue box. So here the QPC takes the user queries and converts it into a flow. First steps are query rule conditioning, where entity extraction is done, taxonomy, and some linguistics for the search geeks out there. The transformer is where a template is transformed to a query text, like who is somebody that is going to be really a user searching for somebody else or a person. So let's transform that into a people search or something. And the query router is one of the more important ones. Here's where we see separate threads, like the remote SharePoint flow, makes calls out to SPO and other federated sources. And the SharePoint search provider flow, this is where more parsing is done. Word breaking, linguistics, heavy lifting is done here, like stemming, synonyms, stop words, security trimming. The actual call out to the on-prem indexer is here. So, and finally, some post-security trimming that's done there too. So the results all come back from those flows and have a little cocktail mixer at the end. Relevancy is done here as well. And for the index lookup, the QPC will send a query to at least one replica, also known as a cell, kind of nomenclature there, per partition of the index, because each partition is a literal portion of the index corpus. There's a response from each cell, one per partition. From this message, we can see the total waiting time which will be at least as long as the slowest cell, the combined total number of hits across all partitions, and the total with duplications. Coming up, we'll show you a slide that visualizes these settings. So, and then everything goes back to the user with timings noted around it, and we'll see this in the QP slide in the next session. Next slide. All right, we see these timings in the query latency reports on the UI. These are a huge resource. Definitely check them out if you're having some, some slowdowns or issues there. So what exactly does object model and backend mean on this report? And this is a report you're going to see, you're going to go to. This is the first thing you go to if someone's having a problem with their queries. So light orange, if you want to focus on WFEs running hot, CPU, memory's an issue, SQS and endpoints are down there, so definitely check that out. For dark orange, that has separate reports, which we'll follow through an example in the next slides. Here in the main flow report, we see query routing is the primary latency time for all of the queries. This should bring you back to the search flows from earlier that we just talked about. Note that each one of these flows matches that legend. And then going right down the line for the query reports, we go to the index or engine report. This shows the correlation between the query routing and the search latency. Reasons for latency here are most of them related to SAN or disk issues or even virtualization issues, something that we talked about in the best practices of deployments earlier on. What you want to look out for here are large spikes for single nodes because that mixes up your complete average. Take those out of the farm, resolve, or speed it up to speed up overall queries.
And notice all these cell timings. This is a callback to a couple slides ago where it's showing the response back to the query component, and it was showing each of the cell times going on. And again, just cell is another word for replica, but you're going to see cell used more frequently, like you do here in this ULS log message. Just cell is kind of how it's referenced internally in logs. So that's why we kind of went for the word cell versus replica. But cell and replica, synonymous.
A lot of data here, but we're coming one more slide, I promise, then the demo. And we have internet. With the introduction of the November 2014 CU, again, the December 2014 CU is a great baseline. If you can't go that forward, November 2014 is great. There is a method here for allow partial results. You can turn this on, and it will give you partial results at the farm level. Again, keeping search up is kind of the main attraction there. After enabling this feature, if one or more of your search replicas or even partition is degraded down for maintenance or has gone down unexpectedly, you'll still get search results. That's great. Two partition farm, big deal. But when you're up to 25 partitions, you have one partition down. You have one replica. It's 50 index nodes. You have 2 boxes down. That completely takes search down. You don't want that. So end users will still receive search results from available indexing components. Great for sites that have SLA around search, keeping search up, 5 nines, that kind of thing. And also gives better flexibility around topology architecture. What is also worth noting here is that all relevancy and refinement results are returned from any available and responding index partitions. And every return result will have complete summary info for like a consistent UI rendering. We're going to see that next in the demo. But something that is worth noting here also is that if you have a promoted result and it's in the partition that's down, it's not going to show up in your search UI. But search is still up. Okay, again, let's see a demo of that.
Crossing fingers.
8. And we have internet. Yay! Okay, so this is a demo SSA that we set up for this, and we have high availability for 20 million documents, and you can see that here. All of these boxes are up. We have 2 partitions with 1 replica each. So I'm just going to do a quick search for Xbox, and I get results. Great. And we see here that there's about 36,000 results for Xbox. Okay, amazing. Okay, so I'm going to run your demo first. Is that okay?
That's cool.
All right. So, if I can do it right. So what we're going to do here is this is an extension of Newt-Braun's script to give you the search topology status. And basically what Brian added on here was
this part at the top, basically showing, basically we've got that timer job that's not running on that particular server. And so basically we just integrated into the script, so this should be considered a problem. So if you scroll down to the bottom, you'll actually see the search service is now sitting in a degraded state. But just kind of highlighting, the script again, it's showing you the analytics reporting here. It's showing the components above as well too, and just showing that they're all in a healthy state. This gives a lot more detail when anything's broken, and so it's a really good first step if you're trying to troubleshoot, why a component is showing yellow or red or anything like that. So UI, useless, this is where you need to be.
So let's simulate Doom.
Okay.
All right. So we just had this simulating Doom script where it just goes out and blows away some of the processes that are in the SSA. It kills the timer, and it kills the... it didn't kill all of them.
No, we just lost an entire partition.
Oh, the whole partition's down, right? Okay.
Where might this be going?
Hey, we don't have any search. Search is down. Something went wrong. Okay, let's look at that correlation ID or do something else.
Yeah.
So we go to that SSA first. We see that the partition is down. And then
And so this is, again, kind of reiterating, if you have 25 partitions, you have a huge implementation, and one partition goes down, you don't want search to be just dead in the water here. I mean, that's... here we go.
So we just ran that to allow partial results.
That same PowerShell he had in the previous slide. And yay, refresh,
We got results again. All right. And if you note here, before there was 36,000 results, and now there's 20,000 results. So everything that was in that partition is not showing, but search is still up, even though an entire partition is down. Again, big deal for two partitions, but for when your corpus grows and your index set is 25 partitions wide, 2 boxes being down takes out search, not good. All right, so I'm leaving it to you. And then we're going back to the...
Yeah.
All right.
So let's see here. Let's do...
Are we fixing it now, or are we going to go to...
Oh, you're right.
5, right? You're up, buddy.
All right, man. Okay, so in SharePoint 2013, we have some great reports for monitoring and troubleshooting search, as Chris demonstrated with some of the query reports. But we still hear the question, that's nice, what's it mean? And so for troubleshooting like any sort of crawl or crawl performance, I mean, this is one of my favorite starting points here, because it shows you the number of items that are currently being processed and broken down by a particular stage. And so to explain this, I like to use the analogy of basically cars on a bridge. Again, we're looking at this chart is the number of items. So if I have a bridge, there's only so many cars that can fit on the bridge at any given time. And when I have a search system, depending on how many crawl components I have, content processing components, how many CPUs I have and threads and what performance level, there's essentially a cap on the number of transactions we can kick off at any given time. A transaction is being used to then process a particular item. So there's only so many things we can be working on at once. And so that's kind of what we're looking at here, looking at the number of cars on the bridge. And so when we're looking at this chart, again, think the number of cars on the bridge here. And how many how many slow green cars do we have on the bridge right now versus how many slow blue ones do we have? And actually, even to say slow is a little bit of a misnomer because, they may all be going 100 miles an hour. You're totally filled up, but they may be just flying through there. So this report is really just showing you where things are pooling up going through this process. And if you look at it at a highway and you see, a lot of cars on the highway, if you just saw a picture of it, your mind's going to say they're probably going slow there. So, finding the areas where things are pooling up, and that's where you want to kind of start focusing your efforts here. So the next slide we have is the crawl latency. And this is now showing how fast each of those cars are going. And so basically similar type things here. The repository time is usually where we see the most, big, ugly parts of this chart. But in this scenario, we want to kind of show something different. And again, it's time in CTS, the content processing. So exactly what we had. Just it reiterates the point where we saw a lot of them pulling up. We saw a lot of them pulling up. This is telling us that they're going slow too. And so that's clearly the longest stage. So to dig into this one, we have the content processing by activity. And so you can see that the shape of this big one that has a lot of yellow in it is the exact same shape as the blue from kind of the bottom right corner. And so specifically what we're going on here is time and indexing. And again, what's indexing? Well, what does that really mean? So to explain that, I'm going to go a little bit of a deep dive for a second. So we have a partition, and within a partition we have multiple replicas that are going on. Within the index component, index processing component, they're actually managing a cell, and this is where that cell nomenclature comes back in. So the cell is really the logical representation of the disk of the index being managed. And so we see for the naming convention, it's basically replica 0, replica 1 that we have here in the first number, and that second number, that orange 0, that's on both of them, that's the partition number. So you're going to see this naming convention all over the place. And again, we've already seen it in some of the logs, and we'll see it more here. One of these is going to be primary. It doesn't. I mean, it could be, I10 could be the actual primary, but one of them gets elected as a primary component. Basically, which one is the most up to date? The primary admin component's managing that and just keeping those on. But the content processing component is going to write only to. It's going to submit new content only to the primary index replica. And it comes in and it's got to feed it in there. And then you're going to see that basically propagate over and push that over to the replicas to keep those up to date. And this is going to continue on, and they push over. But the key part here is that as each one of these are coming in, basically that number on there, it's called a generation, and it's essentially a high water mark of where content is on a given replica. And that's actually how the admin component figures out which one's most up to date, which one has the most recent generation. But anyway, so as they commit onto each of these cells, they're actually talking back to the search admin component. And so this is where you want to be careful of not putting your search admin component on a server that's just going to get hammered. I've done that in my test labs where I'm trying to just be cheap on resources, and I put my primary admin component on a server that's just probably the lightest weight. And I saw crawl performance actually get impacted because it's having to do this callback to that server. And so it doesn't need a whole lot of load or effort for the admin component, but just realize that there is traffic going across and actually talking to that primary admin component to check in and say, yep, I've got this particular generation now committed. And so kind of looking at this indexing activity, I mean, what we want to look at is, do we have our antivirus exclusions, IOP requirements, data path set correctly, network saturation, CPUs, I mean, are they parked? Is this a virtual machine? And do you have the CPUs on a low performance plan so that basically the OS says, you're not really using those right now, so I'm going to steal some of those back. And when you need them, I'll give them back to you. But it's not usually able to do it fast enough to give it to index to do that query. So if you look at this slide, all of these should really look almost exactly like that first slide that Chris had early on where it was saying, the best practices and some of basically that wall of text that we had early on. We've tried to minimize the number of wall of text slides we had, but yeah, this one should really be a callback to that. I mean, this is almost the exact same. All of those things are going to come back and impact index. So now we're going to... Yeah.
What you want to do here?
Yeah.
All right.
So let's go ahead, and we had some doom that happened earlier. So now we're going to go through and let's run that get topology script again. SP search topology.
Control 4.
Yes, thank you. Control 4.
Mouse works.
So we're going to run this again. And now we're going to see we have several of these components that actually the timer job isn't running on this box. But more importantly, we also have a couple components here that are listed that are just unknown. I mean, so we have servers with unknown state components. And so basically what we're going to do is I kind of want to show, let's see here, let's clear this out.
Control C, I think.
No, can I not clear? There, I cleared that time. Where are we at? Control 4. I will get it back there. You were hiding here.
It's hiding. Should type clear again, I think.
There we go. Oh, yeah, we're hung up on. See what's going on. So basically, since those components are down and unresponsive, it's literally trying to call out.
Yeah. It's going, hello, are you there?
Yeah, right now. And it'll time out here in a second. So basically, we're trying to talk to index partition 1, and we have no representatives, so it's hanging up there for a second. But as soon as it comes back, which when we've practiced this before, it was pretty quick. Pardon me?
Can't hear him.
Oh, yep, gotcha.
Yeah. There you go.
Okay, so anyway. Just want to kind of dive into those components and kind of show you how you can research these two. So we have get, SP, enterprise. We have really horribly named commandlets here. Search, service.
They're so short.
Application, yeah. So we got $SSA. And again, we said there's the active topology. So this is basically just the object we were talking about earlier that has all those components that we referenced. But in there, we have get components. And it basically lists out all of our components. And that's pretty long, what's going on. So, but you can see all the components that are listed out and get some information on that. So let's make this a little cleaner. Let's do the same one again, but let's just select name and server ID, server name. And scroll down. And so we can see each of the components. And then likewise, we can do something, not to get too trivial, but get process, node runner, and do it on a remote server computer. And let's do Frank. And so we can get our node runner processes that are going on that server. So what I wanted to do is kind of tee this up, and these are some of the building blocks that I'm using. We actually have a script that goes through each of these servers and gets each of the processes and services that are relevant to search, and just kind of looks and see what's the status of them. So it's not really a Ninja Cat, and we can see.
That does a stop service.
Yeah. So,
basically, you're taking all of those, very long command lines.
Let's try that again.
A nice, quick script, and the script is available.
Yeah.
On Brian's blog.
Yeah.
We'll show that
but point being is you can see status, timer job status, timer stopped there. You can see, so not really anything too important, but just quickly see that we have stop services going on here. And then so just a quick one to fix that. All it's going to do is just go out and actually restart all of those services.
Bring it down, drag down.
Yeah. Trying to.
Oh, that too.
Oh, nice. Well, it stopped on the other one. All right. So if we run Ninja Cat again, now all our services are started back up, or should be starting back up. Didn't do it on Dennis because we manually killed that one. See, this didn't happen in our test because whenever we were going through this live, we didn't lose network. So, yeah, we skipped over a demo, and that's why that's coming back to bite there. Anyway, the point being is we got all those back up and now, and if we go to just restarting the services, restart here.
There it is.
Yeah.
Green.
Yeah, and I'm also going to just restart this guy. Properties, disabled, automatic, and start him. Okay.
Now you know it should work.
All right, so those are, come on. We got 5 there. Yay, and they're all back up now. So it's basically just the services. We're done. All green.
All right. So why do I always simulate Doom? I keep running more Doom. So we're going to do, we're going to show a quick demo of simulating even more Doom. And basically what I'm doing is doing the same thing I did earlier, shutting down services on 3 boxes this time. However, I'm going to bring up the indexer on Charlie. This is where my indexer lives on this box, and the services are stopped on it. And I'm just simulating something where, Jimmy, junior sysadmin, decides to just blow away this partition on a production system.
So that was the index path he just wiped.
Yep. Okay, so what do we do now? Did that work, or is it?
It should.
Okay. So we rebuilt it. So we see that indexer is completely down and broken. So what we can do is we can run the get-sp indexer reports. Nope. SP indexer.
And just index.
What's that? Index reports? Yeah.
Tab.
I don't want to do tab there because we'll grab the other one.
Yeah.
So basically what we're seeing here is that this box is going to come back up. Right now we see it's not there. Charlie is down. There's no indexer on that box. Hopefully it's coming back up.
Just in case, run.
Just in case you jump on it or run it again.
Run the fire breathing.
Fire breathing info.
Yeah.
Oh, there we go.
So basically what we've got here is that we've got since he just outright destroyed the index path under there, it's in a state of unknown. So it's not even trying to report. It's not getting health reports for it. And as it's coming back up, it'll take a second. But as it's coming back up, it's just restarting those services. What we're going to see is, no endpoint listening, so we're getting a little bit further along. But if you stop here, we actually see Charlie down at the bottom listed right there. And he's basically in a degraded state. So he's gone from unknown to now degraded. He's coming back up. He's trying to recover. And if you see, we have a generation 0. So that was that same generation we were talking about earlier. So you can see a generation here, active documents. And as we start going through, and there you go. Now we're starting to repartition. He's starting to seed, basically copying from his peer. And it's just going to copy everything back over, bring everything back up to speed. You see Charlie, what do you have highlighted there? He's at 328 meg on disk, and it's going to keep building up over time. And so literally just copying, restoring that particular component.
Oh, there it is.
And now he's healthy again. He's active. So if you go back to that index path, no sleight of hand here. It's the same one. Now it's back again. So it is resilient. It will take care of itself as long as you have multiple components. And so that's kind of what we wanted to show. That.
Cool.
Yep.
All right. And then we're going to go back to 5.
Back to 5. All right. So basically, just wrapping it up. I mean, it's just, so we went through just trying to really show, again, it's building that baseline. It's going through and automating where you can so you don't have to go do these by hand and manually check every day. Using your result sources and query rules to bring, better results to your users. I mean, because ironically, that ends up being what gets, put very last in most implementations is it's, hey, let's build this out, let's get everything going, but we'll do result queries and rules and everything last, and it usually gets left on the table, and usually you run out of money, or that server doesn't get delivered on time, or something, and then it just never happens, and then so you just kind of run out. It's like buying a sports car without tuning the engine or tuning, even adjusting your rearview mirror or anything. But also again, patching, relevancy, and.
Using the usage reports as intelligence to make search users the very rich search experience. I think that's what we want to definitely focus on. And again, everything is very resilient if you take care and allow partial results, keep updating, and
I mean, in a point, I know this presentation was labeled SharePoint 2013. But from anything we've seen so far, going from 2010 to 2013 was a pretty big jump and change in technology. I would expect, I can't say this definitively yet, but I would say from what we've seen and all these principles that we've talked about here, these should apply in 2016 as well. There's not, for the most part, everything we've seen is going to be applicable in terms of even just concept to 2016 as well. So take this away for all of those.
So search engineers at Microsoft.com will reach all of us, our whole team, if you want to use that. Our blog is excellent. It's very busy. We have all of our team blog to it, and it all melds up there. Yeah, take a picture of this if you're interested.
Yeah,
this is how to get a hold of us.
So all of our individual blogs aggregate into one for our team. We have some members that actually post directly to it as well. But definitely reach out. And if there's anything, especially when it comes to, you have questions on search, come talk to us. Reach out to your TAM if you've got one, and have them help engage us. We'll help you. And that's kind of our focus. And kind of in the mind of services, if we didn't deliver anything today that you were expecting, thought we were going to cover some other topic or wish we'd come talk to us now.
Yeah, let's make it right. If you don't think this is a 5-star, session, let us know how we can update it and fix it and make it better for you next time, or we can just chat.
Please don't punish us for the network.
Exactly.
Thanks, guys.
All right, thank you.